Hello and welcome back to At the Symposium. Today we're going to be working on exponential equations with a common base. Now, this is something you're going to see probably in Algebra 2 to college algebra. It's going to be the more advanced side of algebra. And all we're going to do is try to solve this equation that we have in our exponent. We're usually seeing an exponent like, let's say if we have this 16 here, 16 to the second power. We're usually just seeing it as a single number. Here we're going to see it as an equation that actually has an x value, and we're going to solve for that x value. So how we're going to do that is first we're going to try to figure out what the common base is. The common base is both of these problems have a common base, and all that means is that there's a common number between the two of these that these can kind of be reduced to the power of, right? So we can use the same base to the power of whatever that'll give us these numbers. So we're going to reduce these numbers first, our base numbers, which will be in this case 16 and 32, and then we're going to solve our equation. So let's figure out what the base is. The common base can be figured out pretty easily if you just do if you break down your base by factoring it out. So what I mean by that is we can say what goes into 16. Let's say 8 and 2 go into 16. Okay, but now what makes up 8? Well, 4 and 2 make up 8. Okay, and what makes up 4? Well, 2 times 2 makes up 8. So what we have here, what we do is we look at all our factors from the lowest. Our lowest factor here is 2. So we have 2 times 2 times 2 times 2 will give us 16. So that means we have a base 2 to the fourth power. So 2 to the fourth power will give us 16. You can plug that into a calculator, or you can do 2 times 2 times 2 times 2, and you'll get 16. You say 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, okay? So we have 2 to the fourth. Now 32, we can do the same thing. Let's say what goes into 32, we can say 16 times 2. 16 times 2, what does 16 go into? Let's say 8 and 2. 8 and 2, what does 8 go into? 8 makes 4 times 2. And what does 4 go into? 4 times 2, or 2 times 2 will equal 4. So now we take all our 2's. We have 1, 2, 3, 4, 5. So that means we have 2 times 2 times 2 times 2 times 2. So 5 2's, if we multiply 5 2's, that'll give us 2 to the fifth power. So what that's going to look like over here for this problem is we're going to have now 2 to the fourth, 2 to the fourth x plus 3 equals 2 to the fifth. Okay, that's now our new problem. Now what we're going to do, and you probably may be already seeing this forthcoming, is what we're going to do here is we're going to distribute the 4 to the x and to the 3. So we're going to basically distribute with our into our parentheses. So now we're going to have 2 4x plus 12 equals 2 to the fifth. Okay? Now we say, well, what do we do here? Well, it's actually pretty easy. We just basically drop our bases. Okay? We can drop our bases because we already reduced them. We can drop our bases. Now we just have a regular old equation. 4x plus 12 equals 5. Now what we do is solve the equation. Here we're going to have 5 minus 12. 5 minus 12 is going to give us negative 7. So we have 4x equals negative 7. Divided by 4, because remember we don't want to know what 4x is. We want to know what 1x is, essentially just 1x, not 4x's. So we divide it by 4, and we have x equals negative 7 over 4 as our final answer. Okay, it's pretty simple. So that's how we do exponential equations. with a common base. Let's just do one more here. This next one I'm going to show you is one with a negative leading coefficient, which really doesn't change anything up for us, but I just want to do it because sometimes that leading coefficient can throw people off, and it's not really a big deal. So we have here 16 equals 8 to the power of negative x minus 3. Now, again, same process we did here. Luckily, I guess we have a number we already dealt with. This is kind of the same kind of factorization we already did. So what goes into 16? Well, 8 and 2 go into 16. And what goes into 8? 4 and 2. And what goes into 4? 2 and 2. So we have 4 2's. So that's going to give us 2 to the 4th power here. Now, 8, what goes into 8? We already kind of established this, 4 and 2. And 2 times 2 goes into 4, so we have 3. So we have 2 to the 3rd. So now our bases are going to be 2 to the 4th equals 2 to the 3rd, parentheses, negative x minus 3 for the power, okay? So that's going to be our new problem here. And how do we go forth with this? Well, again, just like we did last time, we're going to distribute. So now we're going to have negative 3x minus 9 in our exponent. Now what do we do with the bases? We basically drop them, and we have 4 equals negative 3x minus 9. 4 equals negative 3x minus 9. Now we just solve the equation, right? So we're going to take our constant, do the opposite, the inverse operation. So now we have 4 plus 9. That's going to give us 11. So 11 equals negative 3x. We don't want to know what negative 3x is. We want to know what x is. So we're going to divide, and our answer, we can say, is negative 11 over 3. And that's how you do equations with an exponential common base.